So, first I want to introduce our university, Waseda University, Japan. So, it is located in Tokyo. So, these are the center of Tokyo, and our campus is located here. Waseda University was founded in 1882, and one of the second largest university in Japan. And we have covered almost every area except medical school. And this is our mission statement, which was declared by Professor Okuma. He was the founder of our university, and he was also the prime minister in Meiji era in Japan. He said that the preservation of the independence of scholarship, the promotion of the practical application of scholarship, and the fostering of good citizens. That is quite important for us. So, I belong to the Faculty of Science and Engineering, School of Creative Science Engineering, before I retired from the university 2020, just at the time of the COVID-19 spread in all over the world. I don't know what does it mean, but anyhow, that was just a coincidence. And okay, I want to show you the short video of the introduction of our university.
One of the reasons why I chose Waseda is for its international student body. Not only are there many international undergraduate students, but there are also exchange students from across the world who we can exchange our opinions with in class. As social science students, we often have group discussions on global issues like climate change and human rights issues. Being in a class with an international student body has helped broaden my perspective and understanding of such issues. Why for both Tokyo and Waseda, I think, comes down to two things: support and access. Even outside courses, Waseda has ample support, both on campus and through partner institutions such as the National Museum of Art, Nature, and Science. There are theater performances, academic conferences, guest lectures with world-class speakers, and all of that taking place in Waseda's inclusive environment, which goes above and beyond the already very high safety standard of Tokyo.
Waseda has a wide range of highly competitive English language programs, from a faculty that's consistently improving over time, where some of the professors having taught at some of the best and most prestigious institutions in the world. I also believe that Waseda University offers really differentiated Japanese programs for different proficiencies, even for non-Japanese speakers like myself when I first came to Waseda. So this allowed me to integrate into my life, especially within campus and off campus also. Waseda also has a list of highly competitive partner institutions, which allows students here to see different viewpoints and analytical perspectives, either through taking classes here in Waseda with international students or exchange students, or having to go on exchange ourselves in all countries. I'm also very interested in the traditional highly prestigious university offerings and have for postgraduate studies following up tenure here in Waseda.
I chose Waseda University because it's the School of Creative Science and Engineering, a great program, great professors who show genuine interest in supporting the students, and cutting-edge research in laboratories. Waseda has a wide variety of English-speaking programs, and even if you're not comfortable with Japanese, like me, you can still study at this.
Waseda has the largest dormitory in Japan. It's called Wish. I used to be a resident here in my first and second year, and now an RA is supporting all the residents living here. What I love about Wish is its diverse culture. People from all around Japan and the whole world gather together, and by living with all these diverse people and communicate with them, I get a lot of new ideas and inspiration. It was said that there are various kinds of scholarships. In my first year, I was granted the partial tuition waiver scholarship. Moving from Hungary to Japan, it costed me a lot of money, and getting this scholarship helped me and my family to start my university life in Waseda.
Waseda is a great academic opportunity, especially regarding your future career. There are so many seminars and internships arranged by respected companies around the world. With the help of the Career Center, as well as the wonderful people you meet, such as professors, senpai, and alumni, you can really find the support that you need. Being able to hear from those who have once been in my shoes and getting the chance to ask those questions that can only be answered with experience is something I'm truly grateful to have here at Waseda.
Waseda is an amazing university, especially in terms of its internationality. I was first fascinated by how diverse students are. There were a lot of opportunities for me to communicate with international students, to make friends and cherish other values and so on. Now, thanks to these experiences, I work as a student staff at the ICC, Intercultural Communication Center, to create diverse international events that promotes interactions between international students, Japanese students, and also have a better understanding of each other. For future applicants, I can proudly say that Waseda is one of the best options to make one step further into the world.
私の名前は竹谷美希です。日本出身です。
Thanks for asking. Hello, I'm Benjamin. I'm from Singapore.
Sziasztok, gyarmatirékának hívnak, és Magyarországról jöttem.
I'm Adriana, and I'm from the island of Guam.
안녕하세요. 저는 민지구고요. 한국 서울에서 왔습니다.
Okay, but actually we have many national universities as well as private universities, and Waseda University and Keio University are the top private universities in Japan. So that is a true story. Okay. So let's go into the main topics. So the maybe overlaps what Professor Data told this morning. But anyhow, so this is just a fundamental of the circular manufacturing. So, and because of my poor English capability, I cannot explain, or you may be not unable to understand. Then please interrupt me. So and ask more, explain more. Okay. So as you know that global warming is a serious problem, and this shows the increase of the GHG, global house gas emission, by sector and per capita in these 50 years, about 50 years. So it increases constantly in these years. And this is in top emitting economies and estimated uncertainty. So in total, the total amount, in terms of the total amount, China is the number one in terms of the emitting the GHG gas. So, and if you look at the per capita, USA was the number one, but now the Russia becomes the number one. And this is the ratio by country. Again, the China is number one, number two, United States, and third, India, because of the number of the people, population, and Russia, and then Japan. So Japan has a 1億だから、100,000 people, just maybe the 1/10 of the Indian, more less than 1/10. So, but because of the development of the industrial sectors, so we emitted a lot of GHG. And if you look at the historical changes, of course, the CO2 concentration fluctuate time to time, but since the onset of industrial times in the 18th century, so they never, it never exceeds the 300 ppm, but now in recent years it became 427 ppm, so very steep increase. And why the CO2 emission is the problem? Because it causes the global warming. And of course there are some people who poses the question about this fact, but if you look at this graph, this is the dark blue shows the CO2 concentration in the atmosphere, and the light blue shows the temperature change. And this is now, and this is several 100,000 years ago. So although you can see the very close correlation between the CO2 emission, CO2 concentration, and average global temperature. So this is measured by the ice core in the Antarctica. So South Pole, around the South Pole. And if you look at also this situation is also proved by the simulation. This shows the simulated temperature change using only natural factors. And if you use the or include the human factors, then the simulated temperature change coincide with observed one quite precisely. So this is another way of proving the correlation between the CO2 emission and temperature rise. And IPCC predict how much temperature rise will happen in the future. And IPCC set 5 different kind of scenario. And if you see the worst scenario, temperature will increase by 5.7 degrees in 2100. So, of course, in Paris Agreement, the target is below the 1.5 degree, but if you continue the same way, we continue to same way, then the temperature increases extraordinarily. So maybe you know the mechanism of the global warming. So the sun the solar radiation is come into the earth and then raise the surface temperature of the earth. At the same time, the heat is remains in the captured by the greenhouse gases, and it keeps the temperature of the globe in certain degree, certain level. And if it is not so much, then that is good for us. Otherwise, so the temperature of the globe become quite low. But if it exceed if the heat captured by the CO2 gas, GHG greenhouse gases increases, then the temperature of the globe increase. That is the mechanism of the global warming. And this causes a different kind of the risks. As you may know, that flooding, breakdown the infrastructure network, mortality, morbidity, food insecurity, insufficient access to drinking water or irrigation water, loss of marine and coastal ecosystem, loss of terrestrial and inland water ecosystem, and so on. And when you look at the rise in the sea level, it is predicted by the worst scenario again. It raises by 82 centimeters. So that is disaster for the many small island countries in the Pacific Ocean. And you may experience already super typhoons. We had in Japan many of them, and very heavy rain causes a flood. We had this kind of the phenomena recently many times in Japan also. Flooding and wildfire. You may know that in California or in Hawaii, and also we had in Japan also this kind of the disasters. And also you see that glacier disappeared or decrease of the ice in Arctic or the Antarctic Sea. So this was the problem of the global warming. And another one is the resource consumption or resource depletion. This is the change in the increase of the material extraction in these 50 years. Again, the amount increases constantly. And this is the prediction of the material use. And so in BRICS, because of the development of the countries, the use of the material increases significantly in these countries. And also this is the prediction of the material use, and this is the level of 2017, and this will be doubled by 2060. Although we have a lot of effort, we will make a lot of effort about the structural change, such as the selling the product, instead of the selling the product, sharing the product, and so on. And also the technological change, like carbon capture and storage technology, and so on. And if you look at the metal material, this shows you, I'm sorry, this is quite small letters, but these are the kind of the metals. And this is current proven reserves. And these are the consumption of the cumulative consumption until 2050, and many of them exceed the current proven reserves. So we will have a resource depletion problems. And about the metal resources, so the problem is not only the total amount of the metals used, but also when you extract that metal from the earth, you need to dig the lot of other material, such as stones and so on. So that is measured. That kind of the materials are reflected in the indices like TMR, total material requirement. And for example, this is a gold, and if you take 1 ton gold, you need to excavate 1 million, more than 1 million ton. So that is another problem. So there are many issues in terms of in the resource supply. As I told you just now, this is environmental problems in the mining, and also maldistribution for the conflict material, and the fluctuation of the prices, and so on. So therefore, what we need is so-called decoupling. So Professor Data already mentioned this concept, decoupling concept. That means that resource use or the environmental impact should be decoupled with the economic activity or well-being. So this is the aim of the solving the problem, but the current, if you look at the current situation, in global GDP and the resource consumption correlate quite with each other. So if you look at the so-called resource efficiency means total value, created value, divided by the material consumed. So just one unit of the, how much value you can create by using the unit material. So the G7 countries, the efficiency increases, but the BRICS, the efficiency stays almost the same value, and therefore, if you look at the world average, it does not so increase. So this is quite a big problem for us. And planetary boundary, this is also mentioned by the Professor Data this morning. And you know that in evaluation in 2009, 7 boundaries assessed and 3 crossed. And 2015, 7 boundaries assessed and 4 of them crossed. And recently, 2023, 9 boundaries assessed and 6 crossed. So situation become worse, unfortunately, because in spite of the different kind of effort to mitigate this kind of the problems. So, circular manufacturing. The concept of the circular manufacturing is that in former times, we extracted the material or the resources from the earth, and then production, distribution, usage, and end of life, and then disposed to the nature. And as also this is already told by Professor Data, if the capacity of the earth is enough compared with our social activity, then this kind of the loop can be continued or the sustainable, but the amount of the extraction or the amount of the disposal increases quite rapidly, then this kind of the system is not sustainable anymore. So what we need is to make a feedback loop or the return path in our society, social and economic society. So this is the basic concept of the circular manufacturing. And as you may know that this is so-called butterfly diagram proposed by Helen MacArthur Foundation. and it is referred by the action plan issued by EU in 2015. And the left side is agriculture, forestry, and fisheries, and the right side is our industrial. And as I told you that it is around 2015, but already in 1994, Ricoh company, which is a copy machine company, proposed the so-called comet circle. And this shows the clear picture of the so-called circular manufacturing. And Ricoh started to design for reuse and recycling already in 1900s, yeah. Sorry, 1990s. And another fact that to support that why this kind of the circular manufacturing is needed is that you know, the urban mine, you may know the urban mine. Urban mine means that we have already extracted a lot of material from the earth. And if you estimate, for example, the copper, almost the same amount. This is you know, this shows the percentage of above ground resources, and this is the underground resource. So almost the same amount of the, for example, copper is also extracted. So of course it's not so concentrated in one area. It is distributed in discarded product or other ways. But anyhow, so if you count what we have already extracted from the earth, becomes a big amount. So the question is why we don't make use of this kind of the material or the resource. Therefore, the need of the circular manufacturing is proposed. And there are many ways to circulate the material. Innermost path is a maintenance. And then product reuse or part reuse or material recycling. And if you use whether the product or the part or the material to the same product or the same kind of the product, then it is called a closed loop circulation. But there is another way. For example, lithium-ion battery for the car is used after the end of life. It is used for the stationary battery to charge the electricity from the solar panel. So this kind of the circulation or the reuse is called open loop circulation, or sometimes cascade reuse or the repurposing. There are many ways to express, but anyhow, so there are so many kind of the ways to circulate the material or the to make use of the value of the material. But if you look at the current way of the circulation, I should say that these are the reverse path. It is called this called the reverse path, but the current system is most of the current system is just supplemental processes with the conventional linear processes. Just the conventional, you keep the current system and then attach the feedback loop. But I think that in ideal system of the circular manufacturing should be this way. So which I call maintenance-centered circular manufacturing. So this means that you don't discriminate new and reused. You should not discriminate new and reused items. So of course, new items and reused items has a different level of the functionality, but not all people or not all customer need the top level of the functionality. Someone can satisfy with the, for example, the 80% of the highest one. So in this way, depending on the user requirement, the product with the certain level of the functionality should be provided. This is this kind of system then can make use of the value of the material or the product more efficiently. So this is my opinion, but this kind of the system is the ideal situation of the circular manufacturing. But anyhow, so there are so many ways of the material or the product circulation. So, and each product has a different characteristics. For example, so this is a bit old data, but sorry. TV DVD recorder and a professional camera and hard disk. So they have, so this is the impact or the environmental load of each life cycle phases. So material, production, delivery, use, and then the life. Therefore, so we need a proper way of the circulation, depending on the order which fit to the product characteristics. And also, we need a right way of the product life cycle management, because many designers make a lot of effort for the design for recycling, for example. This is indicating the number of the screws, or the, you know, that the direction of the screw should be unified for easy to disassembly. So this kind of the effort has been very much researched, and also in practice. Many are applied in a practice, but sometimes, when the product returns, they are just shredded. The whole things are just shredded without disassembling. So this means that you need to manage the whole life cycle in an appropriate way. Otherwise, the effort made at the beginning of the life cycle doesn't mean anything. So therefore, we are saying that we need life cycle planning before designing the product and processes. And this is what we call life cycle development. The life cycle planning means we should consider the product concept, life cycle strategy, life cycle options, and business options. And then based on this planning, we should design product and design processes and implement it, and then get the feedback from the actual situation to improve the next life cycle planning. So why we need life cycle planning is that life cycle options. Life cycle options is options are the method to reduce the environmental load or the resource consumption in manufacturing, such as reuse, recycle, reduce, such as 3R you may know. And product and process should be properly designed and also managed. And proper business model should be designed, because just selling the product is not so, in many cases, not so good. So, for example, providing the product, but providing also the maintenance service, or not providing the product, but providing the functionality in terms of by sharing the product or the subscription-based provision of the product and so on. So there are many ways of the providing the functionality. So this should be selected. That we call business model design. And this is some example of the categorization of life cycle options. BOL, minimum resource input, MOL, middle of life cycle, minimum resource consumption, and end of life, minimum waste. And so miniaturization, dematerialization, and so on. So these are the also well-known ways to reduce the material consumption or the environmental load. And also, there's another way of the categorization. So this is quite well-known one. Professor Bocken of Maastricht University proposed that narrow, use less, slow, use longer, close, use again, and regenerate, make clean, or the remanufacture. Okay, so at the end of this my presentation, I would like to touch on the business option a bit. So you may know that the job to be done theory proposed by Professor Christiansen. And he said that what a customer wants is a whole, not a drill bit. So this is a very important concept when you think about circular manufacturing. So as I told you that just selling the product is not the only way providing the functionality to the user or the satisfying the user. For example, so this is also the quite well-known business model, power by the hour. Do you know? Is there someone who knows this system? Yeah? Please explain.
I work on aircraft structures, but this is on aero engines. Aero engines, every flight task, when it takes off and lands, they do an inspection. So there should not be any damages on the component, on the turbine blades, on those. There should not be damage. If there's any damage, then we have to replace it.
So the Rolls-Royce doesn't charge for the product itself, but charge of the flight hours. So for keeping the serviceability of the product, Rolls-Royce provide the maintenance works or the inspections as you told. And then so they charge the fixed cost per flying hours. So this is one of the way of the, how can I say, so-called life cycle business. This is also the famous one, LaaS, Lighting as a Service. So Philip, now the subsidiary of the Philip, I forgot the name of the company, but anyhow, so provide this kind of the service. They sell not the lamp, but the light. So this is the a kind of the same concept as power by the hour by Rolls-Royce. So they support design, installation, maintenance, and end of life. The same type of the business is also done by the Bridgestone, the tire manufacturer, Japanese tire manufacturer. So they provide a retread service. So just remove the surface of the tire and put another tread on it. And they sell 2 life cycles. The provide a tire to the customer. The customers maybe this service is for the very large tire for the trucks or the commercial vehicles, and they provide to the customer the tire, and the customer uses, and during the usage time the Bridgestone provide also maintenance services, of course with some charge. And then after use of the tire, they return to the factory and retread it, and then provide that to the same customer. So that means the Bridgestone sells the 2 life cycle of the tire. And if the condition is good, then it can be 3 times and so on. And also, in terms of the life cycle business, product service system is a very well-known term. And this is shown by the Professor Taka, and he categorized the product oriented PSS or the use oriented PSS or result oriented PSS. So anyhow, so there are many ways of the providing the product. Sharing economy is another way, of course, as you know. And there is also the categorization of the life cycle businesses, like so-called O-type business. That means that the one company manages the whole life cycle, from production, usage, or the maintenance, and collection, and remanufacturing. So this is a case of the which I recall case. And another type of the business is crab type business. You know that for example, rebuild of the car parts. The company, rebuild company, collect the different type of the parts from the different manufacturers, and then provide different kind of the customers, or the you may know that a cellular phone reuse company, so they buy a different type of the cellular phone and then provide to the customers. Okay, and so this is a bit complicated, but this kind of the business model should be categorized in terms of the role of the who takes the role. For example, so who operate or the who maintenance and who use. So there are many stakeholders about one product. So who owns, who manufacture, who operate, who maintain, and so on. So who takes which role? There are so many kind of the combinations. So if you take one combination, then you can create one way of the business model. For example, this is an example of the just selling the product, the conventional system. Almost all roles are taken by the user. This is the case of the car sharing. Then many of the roles are taken by the provider. So anyhow, in this way, so if you make a circular manufacturing system, you want to create a successful circular manufacturing system, you need to consider the business model as well as how to circulate the material. And so you need to select the proper way of providing the product which fit to the circulation, the way of the circulation. Okay. In summary, environmental and resource issues have become more and more serious, as I told you. As one of the means for coping with the problems, the concept of circular manufacturing has been developed. So, of course, there are many other ways to reduce the problem, environmental and resource problems, but from the aspect of the manufacturing, circular manufacturing is quite important. And there are multiple ways or many ways to realize circular manufacturing. It should be properly designed in terms of product concept, life cycle strategy, life cycle options, and business options. So to gain a better understanding of circular manufacturing, the following issue will be discussed in this week. So I hope that you can. This is a kind of the trigger for starting the consideration of the circular manufacturing. So thank you very much for your kind attention. So if you have any comment or the question, please.
We are still at linear economy.
Pardon?
We are going on with the linear economy.
Mm-hmm.
What makes it complex for industries to shift to circular economy?
It's a very tough question. So, as it's a general problem, so I think that it's a rather radical thinking, but you need to design the circular manufacturing from scratch. So if you, how can I say, if you are stick with the conventional way, so it is quite difficult to change from the linear to circular. So just forget linear, then think about the circular. So otherwise, so it is quite difficult to develop circular manufacturing. So maybe this is just my opinion, but okay. Thank you very much for your question. Yes.
Can't we repurpose the designing factors of the linear machines?
Mm-hmm.
Yeah, repurposing them so that they can be further. Unlike we are, we have created the circular manufacturing machines, now with a circular design. But we have an existing system of linear manufacturing. So repurposing that system instead of starting it from scratch.
Yeah, so of course this is one of the important way, but how can I say? Sometimes so people said that it need more cost, and so for implementing in any system, you need to think about the cost. So industrial people, if the cost is much larger, then they are hesitant to that. So of course, taking back the lithium-ion battery and to reuse is it is not so designed at the first time, but nowadays so the car manufacturer start to think about the end of life already. But this is a very important point. So of course we need a lot of effort for the existing material. But at the same time, I think that you need to design from scratch.
Any more questions? Okay, if not, we can thank Mr. Takata for that.
Thank you very much.